This is part 3 out of 4 of the Parametric Swinging Chair tutorial. In this part, we'll build a chain connecting the frame to the chair. For the chains, we're first going to create a single chain link, after which we will generate the top part of the chain, the bottom parts of the chain, and that will be the complete chain. To generate the chain link, we will start with a torus, and we will expose both of these radius values. So well, we'll name the folder chain. And I'll add a inner radius and an outer radius. Both of these should be at least a millimeter, and preferably less than 10 centimeters. But I'll leave that exposed. I'll leave that unlocked. So we'll take the inner radius and believe that's the second one, and the outer radius I believe is the first one. We will also set the rows of this to 4, and we'll set the columns to 8. And we'll also generate this on the z-axis. Just going to try out some better values. Something like that. Also, let's see. I would like the long side to be the up axis. So I'm just going to rotate this by 90 degrees. And because this is very round, I'm going to stretch it a little bit by just taking that sign again, this time of the height, and I'm going to multiply that by a chain stretch value. So let's see. Oh, that is way too much. And I'm just going to tie that to the outer radius. Divided by 3. Yeah, that's about right for a chain link. You can now mess around a bit more with these values if you want, make them a bit thicker, a bit smaller, whatever you want to do with them, really. So the first thing we'll do is we'll connect 2 of these to these boxes on the main beam. So I want one here and I want one there. Luckily, we already have this line, so we can transform that line because we want it to sit on the bottom of these boxes. So I'm just going to offset it by half of the height of this. now it's sitting on the bottom, and do a copy to points. Oh. Actually, I'll just move this a bit closer. So now we have a chain link sitting on both of these. Actually, I want them to be. I'll get back to this maybe. So now we want to generate a line between, well, a chain between these things and the armrest that we split at some portion down. So just generating the initial line is fairly easy because we know exactly how high up our armrest is, and we know exactly how high up this part is. So the length of this is the difference between the height of transform 6 and where was the armrest again? Right here. So the difference between the height of transform 6 and the highest point of copy to points 8, that's going to be the length of our line. So that's going to be transform 6. Actually, just grabbing the center position for that one, minus which one did I say? Copy to points 8. Okay. I made a mistake somewhere. Right. Forgot to close this quote. All right. So this is the length of chain we have to generate, and eventually we will probably just copy these to the correct place, like this. Well, when we offset them properly, we can do that now as well, actually. Is this half? No, we need to just do -1. But we will do this a little bit later because first we will do the splitting of the chain. So to do the splitting of the chain, we should first decide where we want to split it. So let's resample it for every chain link point. So we know the height of our chain links because we have we have already generated the chain links. But because we want the chain links to sit inside of each other, we're only going to use half of the chain link height. So I'm just going to grab the height of the chain link and multiply it by half. So now we should have many more points. Because we are originating at at 0, and we're going down all the way to however long this chain needs to be. We can easily normalize that, so we can turn that into a fraction. So we have we need the highest point, which in this case is 0, but because it could in theory be different, I'm just going to set this up. And then the lowest point, which in this case is all the way down there. And then we have our current height, which is, so to get a normalized height, so that's a height in a 0 to 1 range between the lowest and the highest point, we will take our height minus our lowest point, and we'll divide it by the highest point minus the lowest point. And I'm just going to assign that as a color for now, so we can actually see what's going on. Just going to hide these points and set the highest as dy max, and this one as dy min. So right now you can see that these bottom points are just from going all the way from 0 to 1. So we're going to use that to decide where to split our chain. So I'm just trying to think how I'd like to do this. I'm going to store this as a variable for now. And then I'm going to, in a split node, I'm going to split between okay, instead of storing this as a value, I'm going to instead create a group. So I'm going to create a input parameter called cutoff. So if norm height is below the cutoff, I'm going to so I'm going to create a group called split, and if the normalized height is below the cutoff value, this point is going to go into that split group. So I'm just going to set that to 0.3 for now. So about like 30% of the way up, it's going to turn from, it's going to add that split group. And then here I can check for this group split, and you can see it has split it off. The other output here will instead be the top of this chain. So what we want to do now, I'm first going to finish the top of the chain, I think, because that's fairly straightforward. Going to add a point triangle, and then for each of these points, if the point number is even, the normal direction will be forward, and if otherwise, the normal direction will be sideways. Or the exact opposite of what I just said. If it's an even point, it will be sideways. If it's otherwise, it will be forward. And then we can, just to confirm that this works. Copy some chain links. And that seems to work exactly as I wanted to. All right, great. So now we can try to do that for the bottom part of the chain, but the bottom part of the chain is going to be a little bit more complex because we wanted to turn into this triangle at the bottom. So we're going to have to stretch it a little bit, resample it again, and then mirror it as well. So let's do that real quick. I'm just going to yeah, let's do that. So how far it should split by is should probably be dependent on the length of the armrest. So we are storing that somewhere. Not here, that's not the armrest at all. We are storing that here. I think this also highlights the importance of naming your nodes because I'm struggling to find what I'm looking for. Right, so this just takes the length of the seat. We probably want a bit of spacing, so let's say 75% of this will be the actual depth, or yeah. So let's set up a depth value. It's at 75%. Let's try that out. The other thing we want is the height. And that is the height of this this remaining section of chain. So that will be the Y size. So to calculate this angle, we're also going to use half the depth again, because for the same reason as we did for the same reason as when we set the depth for the legs of the frame. We want half of it to go to the front and half of it to the back. So this suddenly starts to look very familiar because this is exactly what we want to do. So we can just copy this code and paste that back into the node I was working on. And that should hopefully, that currently just gives us the direction, right? Of course, because we want to then we want to do this for just the top point, and then we want to copy a new line to these. So let's actually only keep. I'm just trying to think of the best way to do this. Because maybe I want to. Yeah, okay. I'm going to still use the split node, but then I only want to keep 0.0 from the other side. And do this based on that. Then we add a copy to points. We add a new line. And all we need this line to be is exactly 1 long. The origin is -1. Yeah, so Oh, right, of course, because we're using the sine, and this because it's perfectly in the middle at the moment. The sine will be 0. So I'm just going to get rid of the sine part because we're going to mirror it ourselves later. So get rid of the sine. Why is the height 0? Yeah, of course the height is 0 because we no longer have that height. So instead, we're going to take this height, the height of the calc norm height, and we're going to, oh, actually, we can just take the height of split 1. Do we want to do that? No. I want to take the height of calc norm height, and I want to subtract the height of the straight part of the chain. So to do that, we'll do calc norm height, and we subtract the straight chain part. And that gives us what I wanted. We are going to resample this again. And I'm then going to do the same thing with the every other one has a different direction, and do a copy to points. And now one of the problems is that yeah, the chain links are not properly aligned with each other. For the chain links that were pointing forwards, I instead want to use this normal value. So I'm just going to plug that in as a second input and say grab the normal 0.0. And then for the other ones, I want to make sure that the up vector is pointing in the direction of the cross product between yeah, I think this is correct. Yes. So right now the chain is actually aligned. From there, I want to make sure to make a mirrored copy of it. So I want to flip it on the z-axis. And then reverse all the flipped polygons. I want to merge these two. And this part we'll have to fix though. But now if I merge that with the straight part of the chain, it starts to look pretty decent, other than the area where they all come together. So let's see, how do I want to fix that? The very last point, can I just safely always delete that? I'm not sure. This is the I'm going to try just deleting the last point and see if that works. That seems to do well enough for this example. So in this case, that is the chain. I don't think I don't think I wanted this one, but I do think I want this to copy the chains to the correct locations. And now, if I merge that into here, that looks okay. Let's see if it still works if I adjust some variables. So the oh right, I wanted to be able to control where to split this. Um, and that should always be between 0 and 1. And we were splitting it. Let's see, where did we split the chain? All right, before the split node. Yeah. So this might be a case that we still want to fix. So if this value is exactly 0, we don't use it at all. But let's see if other values do work. That seems to work okay. The only problem now is that sometimes this happens again. And that's fine. That's something we can fix. So instead of deleting that very last point, or maybe we want to delete the last point as well, but instead of checking if it's 0, I think we want to check if, let's see, let's say call this forward, and that is the endpoints modulo 2. And now if it's not equal to that, so now it should just rotate the bottom part of the chain. So the connection here always looks like this. I think that's going to, yeah, that seems to be doing exactly what I want. Then we want to fix this this case where if you are not splitting the chain at all, it does this kind of weird thing, and that should be easy enough. We'll just add a switch. So if let's grab that variable. If this equals 0, we'll only use this part of the chain. Oh, that should change the order of these two. And then we copy that. So now if it's 0 exactly, it should only use the straight chain, and well, creates a very unstable chair probably. And then yeah, the higher you set it, the higher up the split goes. You should also be able to adjust the seat height. That seems to work as expected. If you change the blanks, yeah, that all seems to work just fine. The arm height, we should probably cap that to not go higher than the chair. Yeah, let's Okay. I think this finishes off the main part of the chair. From here, I would like to just do some fixing up of some of the issues I created.